Thank you for the introduction, Todd. And again, my name is Kevin, and I actually am not from around here. I'm from Nashville, Tennessee. And my employer, Instana, was nice enough to fly me out here to talk to you a little bit about Instana, but more these microservice applications that we're building out using these new Swarm, these types of things. So before I get started and tell you a little bit more about what we're going to talk about tonight, I do want to tell you and give you a little bit of my background, just so you're like, oh, this dude isn't just a sales guy, right? So I started programming on a Commodore 64 when I was about 8 years old. My parents bought one because they were tired of me tearing apart electronics in their house. They're like, if you stop tearing apart the radios, we will get you a computer.
You don't look 50 years old.
40. I'm embarrassed. All right, so I spent over a decade building web applications on my own. And I don't know, as soon as I graduated high school, I went down that route of, oh, I can build your website, give me some money. This works out, I can make a living at this, right? I don't know, most of my time was spent working for smaller organizations and smaller teams. And what I spent a lot of my time doing was building tooling and automation around development environments and test environments so that developers could easily get their applications up and running in a safe environment that wasn't production. So naturally, when I heard about Docker somewhere around 2014, I was pretty excited about the technology and what it was going to enable the community and the developers that I worked with. And not only that, it would enable me to be able to ship software more securely, faster, better, right? And in that time, hold on, I need to make sure I have the right presentation. I apologize for the interruption.
Getting old?
Yeah, getting old. No, I think we're good. It looks like some of my updates didn't get applied, but I think we're fine. Yeah, well, I'm going to blame, so I was on Linux and everything worked there, and then I switched to Windows. So I'm just going to blame Windows. All right, so anyways, so past few years, I've spent a lot of my time working with organizations setting up Docker in production. The last company I worked with organization with about 100 developers, transitioning them from a monolith into a microservice architecture, and also pushing the transition to Docker as well. At this point now, I stopped working for them and I went to work for Instana, but before I left, we were at somewhere around 700 containers running in production on Docker Swarm, more specifically running on Docker Enterprise Edition. Since then, I've moved on to building stuff in Kubernetes, which has been fantastic, but somewhere, I don't know, it was sometime earlier this year, Docker named me a Docker captain, which means I get awesome socks. See these? Yes. I get awesome socks, that's about it. So I'm also the organizer for Nashville's Docker meetup group and also Nashville's DevOps days. So I'm pretty active in my local community. And when I'm not traveling, I like reading sci-fi, history. I think my son loves it more than I do, but playing Minecraft, cycling, and playing board games and RPGs. So what are we here to talk about today, right? I like to think of this as we're going to talk about observability and monitoring. But more specifically, there's two real parts of this talk. One is I'm going to go through a lot of the technologies that exist today that are free, that you can go and download, install in your environments, and start monitoring without spending a dime. You're going to spend a lot of time, though, getting that stuff up and running. You're going to spend a lot of time writing your dashboards, writing your rules, and we're going to talk a little bit about that. So what is the solution? And I kind of hint on it on the second item there. It's automation. When we talk about DevOps in general and the process of shipping software, we want to try to be as deliberate as possible in automating these systems and setting up things to where we just walk away, take our hands off of it, and let it do its thing. So once I get done talking about the open source tooling, and if you have your computers, I do have some URLs for you to play around with: Jaeger, Grafana, Prometheus, and a test demo application I've stood up. But we're going to talk a little bit about how Instana solves the problem by introducing automation, artificial intelligence, and we're going to talk a little bit around some use cases. We're going to do a live demo, and of course, anytime you all have questions, feel free to stop and say, hey, Kevin, I have a question. So let's take a look at what traditionally looks like a monolith versus a microservice. Anybody up here recognize that thing on the left that we used to do? Probably most of us still do, unfortunately. And then on the right, you have your traditional microservice architecture. Now, there's something missing in the microservice architecture, which I'm going to touch a little bit upon, is message bus. Kafka, RabbitMQ is more of a queue, but it still serves as a transactional plane between your services for them to communicate. And monitoring that is critical, and we'll talk a little bit more about that too. So when a microservice goes offline, you lose a service and you lose some functionality with that service, but everything else still generally works. Your UI is going to work. Other applications that aren't tied to that one outage is going to work. Now, what does a monolith outage look like? A little bit something like that, right? When a monolith blows up, you know it's broken because you've got a tire fire. Everything is broken. Nothing works. So let's go back to this. It's hard to detect that. It is significantly harder to detect that outage than it is the monolith outage, just because of the nature of the break, of the outage. So again, we're going to talk a little bit about how to do this stuff yourself, how to monitor yourself, and some of the technologies we're going to go over include Prometheus tracing, and we're going to touch on Elk because they've introduced some APM tooling, but I'm not going to demonstrate it because, quite frankly, I haven't had the time to really dig into it. So what is Prometheus and Grafana? How many people here have heard of Prometheus? How many people use it? All right. So Prometheus is a time series database. It stores data in a linear fashion, which means one value after another. There's not really relational data. You can update columns and fields and things can mutate. With Prometheus, nothing mutates. It's all just a series of numbers. The alerting system, and you can hook into it with a tool called Alert Manager, which lets you then broadcast out. You'll write a query, and if that query is true, then it's going to mass email or mass page everybody on that list. It's a fun time. Developers love it. There are a ton of integrations, a ton of support with various languages. We'll poke around a little bit at using Micrometeor and in Java for exporting Prometheus metrics. We won't spend a lot of time on it because it's very focused, but the code's out there and you can kind of take a look at what that looks like. So this is my favorite part of the technology stack in monitoring is tracing, distributed tracing. How many here are familiar with that functionality or that term in microservices? All right. Can I ask you guys, what are you using the software? Not really? Okay, cool. All right, so both Open Tracing, Jaeger, Prometheus, Grafana, they're all CNCF-backed projects, which means there's people working on them generally. And specifically, Open Tracing supports a lot of our languages out there: Java, Go, PHP, Python, Ruby. There's a client for Jaeger for most of those, and most of the Open Tracing libraries work in those languages. They can be very difficult to set up, and manage and configure, but once you do get them working, you get a lot of rich data out of them. And we'll talk a little bit more about what is open tracing with some demos, because aids. Does anybody have any questions on open tracing before we move on? All right. So a big component of monitoring is collecting the data, and it's a pain in the ass. So, what are the pain points? You have collection, retention, analyzing, or you could call it alerting, or processing, querying, not in this order. I put them in this order because it spells crap, and I thought it was clever. All right, so defining alerts, again, it's a pain. How many here have written alerts in Prometheus or Nagios, or what else is out there? Do you like it? Nobody has ever raised their hand. Not surprising. And there's another aspect of this that is a real big pain. Not only from the fact of having to do it, is that quite often, whenever we build these new systems, for instance, I remember at the last job, developers decided they wanted to use Kafka. I was like, awesome, let's use Kafka. It's a great idea. And as soon as we got it installed, it started breaking, but nobody understood why, right? So here's a big problem with this, is that how do you define alerts around systems you don't understand? I'd argue you can't. You just have to break it over and over and over and start curating that knowledge and start collecting and writing rules around it and tweaking and massaging it. It's a pain. So when you're using traditional monitoring tools, you're going to end up doing a lot of this work manually. Now, with Prometheus operators, Jaeger operators, those tools have made it really cool. Like, how many people here have used the Prometheus operator? How many people have heard of it? It's awesome. You should try it. Like, I just did a workshop around the Prometheus operator, which is part of the demonstration I'm going to show you. But it's really neat how it makes configuration of Prometheus really, really simple. So when we talk about automation and CI/CD, having to do any of this stuff manually, what does it do? Ultimately, it slows you down, right? It slows down the software process, delivery lifecycle. And if we're trying to push towards more automation, going faster, delivering software more quickly, then this is an anti-pattern, right? So we have to figure out a way how to automatically configure a lot of these things. Thankfully, the community is aware of this, and they too have started building out a lot of the automation in those tools like Prometheus operators. We're not there yet. I think there's some room in the future to grow, but we'll kind of talk a little bit about those here in a moment. So who here is currently monitoring or running a microservice application? It could be containers or not. You could be using Nomad or something. But are you currently monitoring with any type of APM tool? Anybody? Datadog, New Relic, Dynatrace? There's a lot of them out there. How much effort are the engineers spending on building out this visibility? I mean, this is something to ask yourself, right? We're working on a formula to kind of address exactly how much this stuff costs, how much each metric costs in relation to open tracing in Prometheus. So I do want to take a little bit of time to explore a traditional microservice app and what it took to instrument it and get some observability in it. So if you're on your computer, you can go to this URL on the bottom, and you'll get a link to all of these different service URLs. Moment. so y'all can kind of get that open. Did y'all have any questions so far? Yes. So to explain what operators are while everybody's getting out their computers, operators are a way for you to introduce programmatic concepts to a Kubernetes deployment. So it's essentially extending the Kubernetes API to enable you to do some pretty neat stuff. In the case of the Prometheus operator, for those of you who are familiar with Prometheus, you have to configure scrape targets, or you have to configure targets in which Prometheus is going to go out and collect data on. And this is done in approaches for auto discovery, but it's still mostly configuration based. So what operators do is allow you to take custom Kubernetes objects or primitives and then collect those and apply them to a configuration in Prometheus. You're able to define that this group of services can be collected upon by Prometheus, and then the operator goes. You don't have to do anything. So it's pretty neat being able to do that. Let's see. Let me try and bring this up. All right, so this is Spring Pet Clinic, which is a demo application, which consists of several microservices. And we're just going to click around here and just create some traffic. You know, maybe change this owner's name to Ralph. I don't know why, but so. Anyways, we're just making some transactions in the application so we can see it in our monitoring system. And if y'all are doing it too, that's even better. All right, so that's the application that is currently being monitored by Jaeger, Grafana, and Prometheus. If we open up Jaeger, we're going to see our friendly gopher mascot with a very inquisitive hat on. And below here, we'll see the different services which are represented by the pet clinic. We have we should shortly, I literally cannot read that. The live demo God's going to frown upon me today. It's possible. So I had to rewind quite a bit because I'm guessing maybe it's not collecting data right now. But as we can see here, we have some queries that have come in, and you can see the details around the queries. You'll be able to read this on your own machine a little bit easier. But what we're seeing here is actually the internals of the services talking to one another and talking to the database backend. So we can see here that we have a MySQL query that has made a database statement, has made this database statement. And we can actually inspect more about the request. Here we don't get a lot of information about the infrastructure behind it, but we do know that it took 3 milliseconds to respond. And this data can be useful when you're starting to troubleshoot large systems that make a lot of queries and a lot of requests to several different systems, whether they be internal or external. So the next one we can look at is Grafana. And there's quite a bit to look at in here. The resolution is not the best, so I apologize. But if you hit the drop down, you're going to see a bunch of dashboards here. The cool part about Prometheus operators and the Kubernetes implementation is just simply by installing it, we get a lot of interesting details about our cluster and metrics. It looks like we completely dropped off at some point. But I don't know, I'll have to investigate that later. But one of the things we did is within the application itself, we were able to instrument the JVM through Micrometer, which if we go back to the code compare in diff down at the bottom, you'll be able to see that my monitor resolution is not cooperating. We're going to be able to see an aggregation of all the changes that had to be made to this code to enable Prometheus, to enable Jaeger. And I don't know, there's about 300 code. I'm not going to go through all of it here because that's not the point of this talk. But it is there for you to kind of go through and to get a pretty good understanding of what kind of effort it required to install the monitoring tooling for this particular application. And it's going to be different for every application, whether you're using Java, .NET, Python, PHP. None of them are the same. The concepts are still the same of tracing, which is the idea that every request that happens in a microservice environment can have metadata injected into it. And then that allows you to gain contextual awareness so that if you're able to inject data anytime a request is made, then you can see at the other side of that request that injection, that data. And then if you have a back-end system to collect and correlate, then all of a sudden you have the ability to map your dependencies. So again, we're all kind of familiar with this figure eight, I hope. It's the DevOps figure eight. It's the idea that it's a never-ending flow. It's a never-ending cycle. And most of these stages have tools around it to help you automate and make things easier. One of the things we haven't seen in the market really is a solution for the monitoring side of things. How do we automate that? So introducing Instana, how our approach to this problem solves it, in my opinion, a very unique and a very friendly manner. It's very easy to use, in my opinion. So before we get started, though, I do want to touch on a few technology terms and what they mean, because we're going to be talking a little bit about those. First up is, what are endpoints? Endpoints can be anything from a parameterized HTTP request, and that is entirely illegible. So what those are up there are HTTP requests, and I'm not sure why they're so blurry, but anyways, so perhaps it would be better if I open up actual yeah, those are screenshots, and that's the main problem. What I can do though is I can actually open up the application. So to suffer through it together because there's not much I can do about how blurry it is. If I increase the screen size anymore, it turns our application into mobile mode, which doesn't work very well. So what are endpoints? So every service typically has endpoints that it serves. Can anybody read that? What those are? All right. So what you're seeing here is actually a parameterized query. And within that parameterized query, I mean, we can see that we're tracking on average around 100 milliseconds latency. We've got several calls that are happening with the service. Oh, it's 480p, no wonder. It's so blurry. All right, so with each one of these endpoints, you have a discovery cost. You have a cost of instrumenting it, right? So if you're constantly having to build out and define instrumentation around these endpoints in a large application, that becomes completely impossible. So as a result, what Instana has done is we've built out an agent in which automatically loads our tracing and instrumentation package onto the app and automatically collects this information for you with zero configuration. So as a result of that, we are always collecting information about the service endpoints and the services themselves to give you real feedback about the requests that are happening on the system at any given time.
What's your overhead?
It varies, but generally our overhead compared to the competitors is significantly lower. Try a different adapter. See if that helps. So, yeah, that is actually much better. Wow, I can actually go back to the presentation now. But before I do, to answer your question about overhead, let's take this actual application. For instance, within the past hour, we processed around 22,000. That's every single transaction that has come into this application. Services is a bit of a misnomer because each individual database table is considered a service. But realistically, this application, I think, has around 12 or 13 actual microservice applications running. And the overhead on this, I can actually tell you what it is because we track our own overhead. So I think this is an 8-core system. We're sending around 8K of data per second, and our CPU load is less than 1/10%. We have around 100 sensors running on this particular host, and we're using around 75 megs of RAM. So it's pretty low, given what we're actually monitoring on this host, which I can tell you what that is. Based on all this over here on the left side is everything we're running on this particular host. So we have an Elasticsearch, we have MySQL, we have a Postgres database, we have RabbitMQ, we have Redis, and we have around 20 Spring Boot applications running. So I don't know, does that seem like low overhead? I mean, yeah, fairly low in my opinion. And one of the things that we do that I think provides a tremendous amount of value is that when you start looking at the actual transactions that are happening in the system, these are deeply complex interactions. I mean, this particular webhook invoked 382 subcalls, which means 382 actions outside of this particular service. It went out and talked to other things and did other things with different systems, quite a bit. And below, you can see here that we have if you click on this, you can get a pretty good understanding of where in the code this was invoked and the results. And not only that, but we also tie it back to the actual infrastructure itself. So every individual call here, we can tie it back to not only the service, but we can tie it back to the actual infrastructure. So I opened up a new tab, and we can see in here that this particular Docker, what we're looking at the view for is the Docker container, and we can see the CPU usage for it. We can see the memory usage. We don't have any block I/O because we're a stateless service like we're supposed to be. And we also collect information about the JVM. And again, this is all done automatically. We detected a Java process. We loaded our agent. We loaded our sensor into the JVM, and we started scraping this information. And not only that, but we have a pretty good understanding of the technologies that are running in Java. So if you're running a Spring Boot application, we're going to collect information about the request and the session's active. And if we see any negative indicators of a performance problem or of a serious issue, we have a large database of health rules already built in based on the technologies that we detect. And because of that, we are in a position to automatically detect problems and tell you about them. Yes, sir.
Yeah, I was just curious though. I mean, some of this stuff will say zero configuration, but you can do some more.
Zero configuration. This is a mostly a Java-based application. Runs RabbitMQ, MySQL as a database backend, and literally the only thing I had to do to get this information and this level of detail is put the agent on the host and tell it it's key, and that's it.
So you didn't have to do any coding to get this.
No.
Wired any microservices or anything?
No, I didn't have to do any because more specifically because of the JVM and Java and the tooling that it lets you do byte loading and hooking and like all kinds of really neat advanced stuff that people who are way smarter than me know about, we didn't have to touch the code. Now, let's say you're running Node.js or you're running a Go app.
Right.
Yes, you may have to go in there and implement the open traces.
So if you have a Java base product, your sort of home
It just depends on the technology. I mean, so with Go, because of the way the compiler works and the runtime, we're going to figure out a way to automatically hook onto like the HTTP handler and inject trace context. We're working on it. We're going to figure it out. Nobody else has. We'll probably be the first one. Maybe not. Who knows? But with other languages such as Node.js, as long as we have a supported framework and we see one, such as Express, then all you need to do is introduce the library, and we will then automatically find the Express HTTP handlers or the Express database handlers and automatically instrument those. With PHP, I think we're completely hands off now. Like we detect that there's a PHP runtime executing, and then we can just attach to it and do all of our magic. Python might be another, it's hard for me to keep track, but Python might be one where we just have to introduce a library to the code. Ruby is another one.
What about like if you're Microsoft shop?
So with .NET, I think we're pretty close to the point where you're going to be able to just put the agent on the host, and you'll be home free. I don't think we're there yet. Our document, if you go to instana.com and look at the documentation for .NET, we're we spell it out, like exactly what you'll have to do to get your code instrumented. Technologies compared to a Datadog or a Dynatrace, it's a lot easier to get up and running with our solution, based on my experience trying to get up and running with those solutions, because I have tried. I have used them before. So back to what we were talking about. I do kind of want to jump into a problem that I just uncovered. So let me give you a little bit of context to what single music is, because this is actually a live production application. It originally started in my garage. It's moved into AWS since then, because we are actually making money on it. This application takes music that artists upload and distributes it to their customers who purchase the music through Shopify. So we integrate tightly with Shopify. We help users set up their stores to sell their music, right? And we had a pretty big event this morning where we sold, or I don't know, we sold around 10,000 albums. And a new bug was, we found a new bug because we saw, I'm going to switch this to the last 12 hours. And you can see here, I'm going to walk up to here because I don't know if y'all can see this very well. Laser pointer. You can see a pretty big uptick here this morning where we went from around, I don't know, 2,000 calls every 15, 20 minutes to almost 15,000 calls at around 10 o'clock this morning. And the system overall held up. We didn't have any really big problems, but we did notice an issue where we started seeing, we were like, well, this doesn't seem right. We've got a trend going upwards here. So we did a little bit more digging, and we discovered that if we start looking at the list of all the services, I want to figure out where that latency uptick is coming from. So if I scroll down this list and I start looking at some of these, this is a 0 millisecond, so that's not really going to help me. But this one, I can see a pretty steady uptick over time, and that's what grabbed my attention. So, and this is actually a database table. And if you look at here, you can see definitely a logarithmic pattern here of access times going up. And after talking with the developer, what we discovered is that anytime somebody makes a purchase, our billing software was going in and attaching a purchase object to that entity. And as a result, as more and more of these tracks started being sold, that it started growing and getting bigger. And as a result, we were making more and more calls to the database, causing it to slow down. So, long story short, Instana helped us quickly identify a problem. The developer was like, I know what that is, and he's fixing it right now, I think. I hope he is. I don't think we have any big sales coming up like this again for a while, so we're in okay shape. Anybody have any questions so far? All right, so let's get back on track with the actual presentation. So we've kind of gone through what endpoints are and what services are. And we'll just stay actually in demo mode for now. So how do you go about defining what this group of applications are? Because, in any kind of container-based system, you're going to have a bunch of different containers or microservices running. And one of these applications, this particular one, everything that music, so it's not a really good example. But let's say, for instance, you are running you're running a storefront web application, and it started out as just a store API and a customer API with its own database. Over time, you added some workers to handle billing and processing, and eventually you added some game servers, because this ultimately is a game application service. And you added a new game service. So we actually have several different applications and domains in this little mock application here. So what are some use cases and scenarios around that application? What we're going to talk about is performance testing approach. So let's say a developer is working on a performance SLA issue, and audits are coming back that installs are taking more than 5 seconds. And what we can see here, based on the trace analyzer, is that we in fact do have applications that are taking longer than 5 seconds to be installed. So let's inspect one of those traces, and we'll get a histogram of what is happening. And the first thing that we notice is that we're making an external call that appears to be blocking to OAuth token. So what are some approaches that some of you might take to reduce the blocking cost on that? What would be some solutions that you could think of? One approach could be caching. You only really have to make that request once, and then once you have the token, you don't have to do it again. That's actually precisely what we did to fix the problem. Is we recognize that this is blocking. If we introduce a cache, it'll reduce the problem. And actually, I'll show you a couple installs where it's gone now. You can see it. The other one is we have some asynchronous calls, or some synchronous calls happening that could potentially be async. That was never the case. We just had to deal with it and accept the fact that sometimes this was going to take longer than we had anticipated. Now, I don't know if you guys can see what I'm pointing at here, but this is singlemusic.auth0.com. That's an external service. That's something that we don't really have a lot of control over in terms of how long they're going to take to talk back to us. And there's the dashboard for that external service. So outside of seeing when this service is causing problems or how long it's taking, what could be some of the use cases for this? I'm just looking for one, really. Yep, SLAs. So you've got a third breaking their SLA. How do you prove it? Right here. It's easy. You just show them this. So this is the history of my interactions with your service, and it's consistently slow, and it consistently gives me bad responses. Please fix this. So another approach is feature and performance testing. So let's say this team is simply working on a new version of the game server, and all they really care about are the transactions that are coming into that new game server, and that's it. They don't care about the rest of the application that that this is a part of. And this is really easy to do with application perspectives, because application perspectives allows you to filter on tags. So anything that's running in your environment, if it has a Kubernetes tag, a Docker tag, there's a lot of other things that we can filter on. As long as it matches up with that filter and/or, you'll have a perspective, and you'll only see the interactions with these systems. Everything else will drop off the radar. And I'll show you some examples of that here in a moment. So, and here's another one where, you know, again, this is just some additional screenshots where you can see a histogram of a database over time. So you can see the performance characteristics of a query get better or worse over time based upon, did I add some new indexes? Did I do some database magic? So ultimately, like, what I'm trying to get at is that's chaos. And there has to be a simple way to monitor that chaos. And so let's take a look at how we configured single music. Like, we just simply told it namespace is this. That's all you care about. And realistically, like, what is running on this system is multiple tenants. We have several different applications running in different zones, but all that this is monitoring is this right here. And there's other ways that we can, so for instance, let's say that all you really care about looking at are external services, not your internal ones. So configuration is we kind of hacked around and we said, hey, if the incoming call has an HTTP host that matches these, then this is part of that filter. And as you can notice, everything that wasn't a part of that filter isn't in here. We're not analyzing the performance of that and giving you the characteristics of it. The other thing that we have that's really cool is our dependency map. And this is built solely off of the data that we collect based on the endpoints and the services. So what we have here is a real-time display of actual traffic happening within our microservice application. So, and we can also kind of change the view of it based on, you know, all I really care about are the services that are getting the most calls. Well, that's this. We've already talked about this database a little bit, but this one is definitely getting the most calls, and it immediately jumped out because we told the sizing to adjust based on that. So sort on latency, we can see that the email service is one of the more latent services in our application, along with some FTP site, which I don't even know what that is. That's concerning. But so that kind of gives you an idea of, you know, what things you can do when you have a lot of granular data about your service and you're collecting it and you're analyzing it. I don't know of an open source tool that does this. With Jaeger, you can get a dependency map, maybe? No. I heard you can. But for the purpose of this demo, no, you cannot. Still bugs me if this doesn't work. But, all right, so as I click around, trying to find my spot. All right, so what are some of the key benefits of application perspectives in Instana? You're able to define these dashboards on the fly. You immediately get feedback on those services immediately. No need to change code or redefine agent models in most cases. And ultimately, we're going to spend less time looking for stuff that matters. We're going to solve problems faster because you have a tool which is enabling you to gain insights into your application in a way in which I think is tremendously unique and tremendously powerful. And we just went over an example of a problem we found this morning based on like real production information. Now, I may have skipped over a couple things, but does anybody have any questions? Yes.
You mentioned that people hate writing alerts.
Yes.
Does Instana do something to like automatically, like somehow automate alerting people based on?
So we have a couple things that we do. That's a great question. Thank you. One is that we apply machine learning and AI heuristics to the data that comes in. So a lot of information, we're able to apply machine learning to it so that we can for deviation. To do that is because of that granularity. If you're 15 or 30-second roll-ups, machine learning is useless because realistically you're going to be acting on averages and information that isn't necessarily up to date. The other aspect of it is that we do have a really large collection of predefined alerts, and this is really around, we know that when the JVM takes more than X amount of seconds to garbage collect, that's bad, and we're gonna alert you about that. Not only that, but we also have a root cause analysis engine, and I showed you that dependency map. Now, if we recognize that one service is impacted by some sort of disk filling up, CPU, throttling it, unavailability to the database, like the database goes down, every service that is impacted downstream of that, we can correlate because we have that service map. So as a result of that, what you'll see is, I can actually just show you because we do have this. So this is an example of some of the machine learning being applied. So we've noticed that the rating service had an increase in latency, and as a result of that, this application was impacted, and here's the impact of the application. We've had a complete drop of requests, latency jumped up on multiple services. There is an example of somewhere in here, a database going offline. Here it is. So as you can see, we have multiple services in this list that are being impacted by an outage. And what we did is we rolled it up into a single incident so that you're not getting bombarded with a huge page list because 4 different services broke. You only get one. So that is a pretty good example of the machine learning alerts. Another good example, I think, is where and I don't have a good example of it up on the screen, but for instance, let's say Kafka doesn't have replicated topics, or if Cassandra is queuing mutations or something. I mean, we immediately recognize that as a problem, as a performance problem, and we will alert you about it. Yes, sir.
Sort of the nitty-gritty. How is it licensed, and what's the pricing on it?
So the pricing, we have multiple license models. We have on-prem and we have SaaS. The pricing is not different between those two. Our pricing, at it, I think it. So let's just do that actually, because I don't want to give you the wrong information.
Going back to his question
Yes. So products, pricing. So for the application performance monitoring, it's 67 per host. That includes up to 10 containers, like active. We realize that in a lot of environments, there's several containers in which you don't really care about. Kubelet, DNS to SD proxy. Like there's so many different things that Kubernetes will run that you're like, I don't want to monitor that. That's not included. So pretty straightforward pricing.
That's good.
Yeah.
What is your definition of host?
A machine. Like, I mean, it could vary. I mean, we have, like I said, this thing is running on like an 8-core with 32 gigs of RAM. That's a host. This is a smaller machine running 2 cores. I mean, we have customers who are running 32 core machines. That's a machine. Like that's a host. Now, where I think things will probably get a little more difficult and trickier is when we start talking about monitoring lambdas and functions as a service, because those don't have like a physical. They do, but it's abstracted away from the user, right? How do we go about? And that's a question that's somebody else's problem, not mine, right? But we do currently, we will detect lambdas and we will monitor those as well. We're working on automated tracing within those, and that's coming soon as well.
Well, the pricing seems straightforward, which is good for you, because a lot of times you get stuff that says, well, how much does it cost? What are you willing to pay?
Yeah, well, and if I don't know, it sounds like you've dealt with other APM vendors before. Yeah, so we've built this company to get away from that, because we think it's BS. Yeah, it's nonsense. Like you get a PO and it's like, oh, line item price 300,000, your price 30,000. It's like, what? Like that doesn't make any sense. Yeah.
Yeah, really hard to budget that way.
Yes. Yeah. All right.
The difference between the infrastructure monitoring versus the APM
Mm-hmm.
is that like the infrastructure is basically Prometheus's equivalent of Node Explorer, but an APM is the stuff that would attach to the JVM.
Yeah, like so a pretty good mapping is that infrastructure is Prometheus. Like it's just metrics. You'll get information about your containers, you'll get the CPU memory usage, and you'll get the information about your host, which I mean, like I said, we kind of went over what that looks like here. Information about the applications themselves, but what you won't get is the trace analytics, where you're able to see the interactions in between your services and the stack traces. Like, the cool thing about this is like this will actually dig out code. Watch it prove me wrong. But yeah, this will actually pull, like it'll show you the code it executed within your application service. So I mean, like our APM service could, I mean, I don't even, they're definitely not the same. They have similar. In Jaeger, you're going to see the interactions between your various services and systems. So, a lot of these are health checks. But again, you're gonna be able to see the requests coming in, and some of the parameters around it. But like I said, what you're not going to see is that correlation back to the infrastructure, and you're not going to see the correlation back to the code. Those are extra things that we do, and realistically, there's no real alerting in this system. I think you can add You can add metric exporters from Jaeger where you can collect it with Prometheus, and then you can write alerts around that. But don't even get me started about writing alerts, because we've already talked about that. So, but yeah. Any other questions? So before we wrap up, just a couple things. We are giving away a neat little Nintendo thing. You just need to provide your details. I would invite everybody who has a microservice application environment running to to sign up for a free trial. It is free. You don't need a credit card. 15 days, you get to install it and see all the magic that we do, and hopefully we provide some value, like some insight into your application that you didn't know about before. I can say with utmost certainty, every time I put Instana on an environment, it's always exposed some detail or some performance enhancement or some opportunity that I just didn't even know existed. And so it's been pretty compelling so far. That's why I joined them, ultimately. But I appreciate everybody's time. Thank you.